Hi and welcome back to Mrs. Riley's Maths videos. This is video number 7 in a series of algebra revision videos, and this video is about solving simultaneous equations when they are both linear. So when you've got two equations and you're trying to find the solution that matches both, and in this case both of them are linear, both of them are lines. So this kind of links in with coordinate geometry, and if you remember from your coordinate geometry, if we have a set of axes, we've got the line x plus 2y equals 6, which is when x equals 0, y equals 3, so something like this, and 6, 0, which is something like this. So this is one line, x plus 2y is equal to 6, and this line here, when y equals 0, x is equal to 3 1/3, so something like that. And when x is equal to 0, y is equal to minus 5, something like this. So you've got your other line, like, oh dear, badly drawn, but anyway, you get the idea, 3x minus 2y equals 10. So when you're solving simultaneous equations algebraically, what you're doing is finding this point here. You're finding the point of intersection of two lines. Okay, so when you're solving these two equations algebraically, which we'll be doing in a minute, you're finding out what this point is. Okay, so the other thing to remember when you're solving simultaneous equations, which if you're in my class, we use this phrase a lot, it's same size and opposite signs. So what we find out is that if we can get either the x's or the y's to be the same size in both lines and opposite signs in both lines, then it makes them much easier to solve. So let's take our first question here, which is x plus 2y equals 6 and 3x minus 2y is equal to 10. So we write them one above the other. We make sure the x's are lined up, the y's are lined up, and the numbers are lined up. And already we can see here, same size, opposite signs. It's great because these two lots of y. There's plus 2y in this one. Let's call it equation A, and minus 2y in this one, which we'll call equation B. So actually we don't have to do anything else at the minute other than add them together. If we add these two lines, we get 4x, x plus 3x is 4x. The y's will cancel each other out, and 6 and 10 is 16. So now we have 4x equal to 16, so x must equal 4. And this brings us back to another point to bear in mind about simultaneous equations. If we have one unknown, one thing we don't know, then we only need one equation. If we have two unknowns, two things we don't know, x and y, then we need two equations. And if we have three unknowns, like we introduce you to in TY, then we need three equations. So what we're always aiming with simultaneous equations is to get back to one unknown with one equation, because when we have one unknown with one equation, it's really easy to solve. 4x equals 16, no problem, x must be 4. When you've got two unknowns with two equations like here, it's much harder to see what number would fit for y and x at the same time. Okay, anyway, that's a digression. So x is equal to 4 in this equation, but what about y? So to find y, we go back to either a or b. So let's go back to a. And we know now that x is 4. So if x plus 2y is equal to 6, we know that 4 plus 2y is equal to 6. So I'm going to subtract 4 from both sides. So 2y is equal to 2. So y must be equal to 1. So what I found out here is that the point 4, 1 is the point, and actually it looks quite right on my graph, remarkably so. The point 4, 1 is the point where these two lines meet. And it is also the value of x and the value of y that works in both of these equations. 4 plus 2 by 1 equals 6, that's true. And 3 by 4 is 12, minus 2 by 1, so minus 2 equals 10, that's true. So that's what we found when we solved these. Okay, let's keep going with solving simultaneous equations. Let's go down here and work on question 2. So question 2 was x plus y is equal to 7, 2x plus y is equal to 12. So in this question here, you can see the y's are the same size, but they're not opposite signs. Now, so what we can do here is we can do one of two things. we can either decide, let's answer it twice. Let's do it our way by saying get them same size and opposite signs. Let's call this equation A and this equation B. Let's multiply equation A by -1, and I can do anything to equation A as long as I do it, multiply it or divide it by the same number all the way across. So I can make this into -x minus y is equal to -7. That's A. Let's leave B the same way. We've got 2x plus y is equal to 12. And if you notice, they're now same size and opposite signs. Add these two together, I get x. They cancel out, is equal to 5. And if I go back to my original equation, so back to A, I now know that A is 5. So 5 plus y is equal to 7. Y must equal 2. So the answer would be 5, 2. Now, some of you may have looked at that and said, well, what we could have done, surely we could have just subtracted them. And of course you could. So let's do that. The reason we don't tend to do that is because it gets more complicated for people when there's negatives. But by all means subtract. So x minus 2x is minus x. Y, subtract y, cancels out. 7 minus 12 is minus 5. So x is equal to plus 5. And then we can go back to this again. Let's go back to B this time. 2x plus y is equal to 12. So 2 by 5 plus y is equal to 12. So 10 plus y is equal to 12, y is equal to 2. And again, we get 5, 2 as our solution. So if they're the same size and you just want to subtract, you can. We subtracted there. But if they're opposite signs, it means you can add, which people often find easier. That's question 2. Question 3. 2x plus 3y is equal to 9. 4x plus y is equal to 13. So what will we do? We'll try and get rid of the x's this time, make them same size and opposite signs. So that's A, that's B. If we do A times -2, so minus 2a will be minus 4x minus 6y is equal to minus 18. B, as it is 4x plus y equals 13. Add the two together, I get, these cancel out, minus 5y is equal to minus 5. That must mean that y equals 1 if I divide both sides by minus 5. So I've got y is equal to 1. Go back to one equation. Let's go back to B again. 4x plus 1 is equal to 13. So 4x must equal 12. Dividing both sides by 4x is equal to 3. So the solutions to these two equations is 3, 1. If I was to plot them, then they would meet at the point 3, 1. Question 4. 3x minus 2y is equal to minus 12. 2x plus 3y is equal to 5. Now up until this point, let's just label them A and B. Up until this point, I've only had to do something to one of the lines. But you can see here, there's nothing like, I can't really easily multiply 2 by something to get 3. Well, I could do 1.5, but I don't really want to get into fractions. And the same with 3 and minus 2. So what I'm going to have to do is aim for a number that both of them divide into easily. And in this case, I'm going to go and get the y's to be 6y. Because 6 is a number that 2 and 3 both divide into. So I'm going to multiply this line by 3 and this line by 2. Okay, so I've got 3a will be 9x minus 6y is equal to minus 36. And 2b, we've got 4x plus 6y is equal to 10. I'm going to add those two lines together. So I've got 9x and 4x is 13x. Those cancel out. Minus 36 plus 10 is minus 26. So divide both sides by 13. X is equal to minus 2. Let's go back to A this time. So 9 by minus 2 minus 6y is equal to minus 36. Now actually I should really have gone back to the original A. So the original A was 3x minus 2y is equal to minus 12. Now when x equals minus 2, that's going to be 3 by minus 2 minus 2y is equal to minus 12. Minus 6 minus 2y is equal to minus 12. So minus 2y is equal to minus 6. Y is equal to 3. So minus 2 and plus 3. Did I do that right? Yes, I did. Okay, good. Question 4. Question 5. I'll go up here. Question 5 is 3x plus 4y is equal to 23. And y is equal to 2x plus 3. Now, you can see there's a problem here because they're not lined up. So I'm going to rearrange B so that it's lined up. So A was 3x plus 4y is equal to 23, and B is minus 2x plus y is equal to 3. So I've moved the minus 2x to the left hand side. Now you can see if I multiply B by minus 4, I'll get it to be the same size and opposite sign on the y's. So A is 3x plus 4y equals 23. Minus 4 times B would be 8x minus 4y is equal to minus 12. Add the two together. So this was A and minus 4B. Add the two together. I've got 11x is equal to plus 11. So x is equal to 1. And I'll go back to B. Y is equal to 2x plus 3. So y is equal to 2 by 1 plus 3, which is 5. So 1, 5 is the solution. That's where those two lines would meet. And question 6, hopefully I have enough room. Question 6 is nastier again because there's a fraction in there. I've got 5x over 3 minus y over 2 is equal to 12. So I'm going to have to get rid of the fraction first of all, and if you've watched the video on fractions you'll know that we have to multiply across by something that will get rid of the 3 and the 2, which in this case is 6. So A is still, well, let's just do that first actually. 6 by 5x over 3 minus 6 by y over 2 is equal to 6 by 12. So we've got 2 by 5x, which is 10x, and 3 by y, which is minus 3. Yeah, there's a subtraction there, so it's minus 3y. It's equal to 6 by 12, which is 72. So B has now become 10x minus 3y equals 72. And A is 2x minus 3y is equal to 24. So let's multiply A by minus 1 so that we've got same size and opposite signs. So A is going to be minus 2x plus 3y is equal to minus 24. Adding them together I get 8x is equal to 48. They cancel out. So x must equal to 6. And going back to A, I know that 2x minus 3y is equal to 24. So 2 by 6 minus 3y equals 24. 12 minus 3y is equal to 24. Minus 3y is equal to 12. Y is equal to minus 4. So my solution is... Sorry, just glance at that again. So I multiplied A by minus 1, and then I added the two lines together, and I ended up with 8x is 48 and x is equal to 6. And now I've worked through here, and I've got y is equal to minus 4, so my answer is 6 minus 4. Okay, I hope that's useful.